Hi there. In this video, we'll be discussing the core components of a prompt. In more detail, we'll run through what exactly is a prompt and how we use them effectively. Then we'll look into what is a context window and how that relates to prompting large language models. And finally, we'll finish by discussing different prompt types and when and how you should apply them. As a summary for today's presentation, you can think of the prompt as effectively all of your input to the large language model. The output of the model is conditional, or it's based on what you provide as your prompt. So you can view the prompt as a way of steering the language model to generate output in a specific way aligned to your use case. You'll typically in production use something that we call a prompt template, which will enable you to make these applications more applicable to a wider audience by injecting custom data for the use case at runtime. And finally, we'll speak about the different prompt types and introduce the idea of hard and soft prompts, where hard is the type of prompt that you're used to using currently, and soft prompts are a way to change those prompts or improve them using numerical optimization. Like the other videos in this series, I want to give a highlight to the prompt report. It's a great paper, so if this type of thing is interesting to you, I recommend reading that after this presentation. Let's start with the basics. So before we get into prompting, we need to understand, at least at a high level, how a large language model generates an answer or it generates an output. So you can see here in the visualization, we have the prompt as input to the large language model, and ultimately we get the output or our answer or the story or the marketing copy or the classification, depending on your use case, as the output of the language model. This treats the language model, or for example, the OpenAI endpoint, as a bit of a black box. We can peel back some layers of that while still keeping it relatively high level for this basic introduction. So if we go through the flow now, when the prompt or the input goes to the large language model, it's then passed to the core model, which is leveraging something for most large language models called the transformer architecture, which is a style of deep learning model, a style of neural network that has been trained on a large amount of data to generate text, and they've generated basically a probability distribution so that the text that is generated is based on what is most likely from what it's seen in the training data. So we can see this stepped out. We go through our input, the prompt now goes to the core model. We then generate these things called logits. You can view these logits as the output of the core model. That's a significant or a sufficient understanding for there. We then apply some function for them. So the name of the function that we'll typically apply is something called a softmax. This will convert the logits, so the stage 1 output, into a probability distribution. And remember, the language model has been trained to predict next tokens based on a probability distribution. So this is the point where we're getting the probabilities. And finally, for the next token, what we take is the maximum of the probabilities. So like I said previously, the core process you can be thought of using a large language model is predicting what is the next most likely token based on what I've seen in the past. And so I have the repeat icon here because this process is done for each new token that you generate. So you might have as your prompt, write me some marketing copy for my business, and the output is that full set of copy for your product, for your business. What is actually happening is for each token of that, or each word that you're seeing of that generation, we're running this process repeatedly. So we're generating the token, it's being appended back as the input, and then we're texting what is going to be the next most probable token after that. We do that for a series of steps until some stopping criteria has been met, and then we return, or OpenAI returns the output to you from the large language model. So at a very high, broad stroke overview, that is how the language model works. So where does the prompt come into play here? Well, effectively, as I mentioned in that process, the output of the language model is generated based on what's most likely next, based on what it has seen previously. So your prompt is a way of conditioning the output of the language model based on some series of instructions that you want to provide. So you can think of this prompt as a way to steer the language model and to dictate the generation that you're going to receive. For those that are looking for a formula, this is how you can think about the probability of an answer given the prompt. As you can see here, just like the diagram, for each token, so the subscript I here of your answer, That is being calculated as a probability conditional on your prompt effectively, so what's been seen in the past, and every token of that answer previously, so leading up to this next one. So just highlighting again, this process is at each point in time, we're generating what is the most probable next token. And we're doing this process to get an ultimate answer to return as output. The prompt really is your primary control method for therefore generating what is the output. Okay, let's take it a bit more practical and how we would typically use a prompt in production. For most production use cases, you want it to be able to meet the needs and be able to serve a large user base. You're not doing it typically just for one specific user or one specific example. So how we address that issue is we create something called a prompt template. So we have a base, a bones of our input that we want to use for the language model as our prompt. And then we add placeholders in certain areas that are to be injected at runtime to make it applicable to multiple users. So a clear example here is, for example, having a placeholder for your client's details. And then when the generation is run from your database, you retrieve those client details, you inject them into the prompt, and then the output is conditioned on the prompt with the user details for that specific user. You'll also find with these prompt templates and with prompts in general, there are a few common instructions or common techniques that will typically be used. So let's go through a few of those now. Firstly, you have the idea of assigning a role to your language model or a role provided in the prompt. And we do this because it's actually been associated with improvements on performance benchmarks. And you can think of it intuitively as saying, again, we're conditioning this output on what you provide in your prompt and what's most probable next. When we're assigning this role, we're trying to make the most probable output more associated with what somebody with this role would do. So for example, you might use an expert data scientist or an expert salesman to help you with your marketing copy. The directive. This is pretty much going to be core to all the prompts that you use. You can think of this as the actual instruction for what you want this language model to do and what you are trying to direct its output to be. So it could be, for example, predicting the user sentiment or classifying this as fraud or generating ad copy. Those examples that I just gave would be examples of explicit directives, but it can also be implicit. And when we say we're using an implicit directive, what we're saying is we're not directly telling the language model to do X. What we're doing instead is giving an example of doing X and then asking it to effectively continue that trend. So in the example I've given on the screen here, I have an implicit prompt, which is doing an association task. So we're saying bark is to dog as blank is to cat. The language model will then predict meow. You've implicitly told it to do this association task. So to summarize here, typically you'll be using explicit instructions, but you can also leverage implicit ones. Implicit might be helpful if it's difficult to articulate the problem, but they're also important to be wary of because you might be unintentionally providing an implicit directive in your prompt. Style instructions are the next category, and you can use these instructions to basically to bias or to guide the model to generate output that follows specific style and thematic themes. So you might ask it to be concise, or you might ask it to use informal language, or potentially formal or corporate terminology. So with your style instructions, you're trying to guide the nature of the output as opposed to not necessarily the structure. Examples. So you can provide in your prompt either 0 examples, we would call that a 0-shot prompt, or you can provide it multiple examples, in which we would call it few shot. The idea of shot here is the number of examples that you're providing. Sometimes this might even be referred to as in-context learning. And so you can think of where shot is coming into this is the number of shots you're giving the language model to try and pick up on what you're actually intending for. So these can also sometimes result in implicit directives being added. But what you do here is effectively, instead of trying to write out exactly what you want the language model to do, You give an example, you give a demonstration of what the language model should be doing for this task, and you provide that to the model so that, again, when we're generating the next most probable tokens, it's basing it off this example that you provided. So it's going to be more inclined to follow that pattern of the examples you've given. Additional information, this goes back to what I was speaking at the start about the core reason why we templatize these prompts, and that is so that we can use them for multiple users. Finally, output instructions. So this, I guess, can be viewed as a counterpart to the style instructions mentioned before. The output instructions are necessary to have the LLM output the generation in a specific structure. And why we need them to do this process is, for most large language model applications, assuming it is part of a broader application, you need some way to reliably interact with this LLM. And it is a lot easier to do that process if you can beforehand know how the output from the language model is going to be structured. So in your downstream application, you can take in the output of the language model based in this specific format more easily, and you can post-process it. So common ways that people do this here is asking the model to generate JSON, or it could be XML tagging, or comma separated values. These are all examples of output instructions. Okay, so you now have the basics of what is a prompt template and why and how we use prompts to generate output from a language model. One other core thing that you need to be wary of from a practical perspective when working with large language models is this idea of a context window. As I mentioned at the start, a lot of these large language models build upon the transformer architecture, and the core contribution of the transformer architecture is attention. And at a high level, attention can be thought of as a way of providing a mechanism for these language models to build contextualized and nuanced relationships between tokens or between words in your input sequence, so that the ultimate output that you generate can take into account these relationships between your tokens. That's a very high level explanation. But effectively, this context window refers to the amount of information that the language model can attend to, where attention, again, is that core mechanism of the transformer architecture. So, simple definition, context window is the amount of input that the language model can attend to. And the maximum of this, so the length of the context window, is aptly named the context length. Why this is important from a practical perspective is if you try to provide input that is larger than the context window, then the model will not be able to generate based on that information. It won't be able to attend to it. So you'll have to do one of two things. Either move your context window, so you delete some of the information so it now fits in it again, or you try and apply some other technique to get yourself back into a state where your input fits within the context window. Now, as models are getting more performant, this context window is getting larger as well. So that's one of the elements that people are working on for this performance aspect. But if you're fine-tuning a model yourself, or you're using an open source model, then the context window can be a more practical concern. Furthermore, if you're using this in a conversational, a chat-based setting, then it's possible that you might reach some of the context window limits if it's a long conversation. So that is a high-level overview of the context window. Let's try and visualize an example, again, for a chat-based conversation here to see practically how the context window comes into play. So in the gray dotted box, I have the context window. And so again, here visualize the length of this context window is aptly called the context length. In the colored blocks, I have representing here input to the large language model. So we now provide this full input to the language model and we generate an output. So we have a new block here. Now in the conversational setting, what is typically going to be done is we'll take this output and we'll append it to the previous input and we'll continue based on there. So you see we fill up the context window slightly and we generate a new output. Now finally, in this third iteration, if we try and add that output back to the already existing conversation history, we run into a problem where the total input that we want to provide is larger than the context window. So what I've shown here in the example is one approach that you can do to address that, and that is the idea of a sliding context window. So we operate under the assumption that the conversation that has been most recent is going to be most relevant to the next messages in the conversation. And by adopting this logic, what we do is we say, okay, we'll cut off the conversation from a while back that doesn't anymore fit into the context window. So as you can see here, the dotted rectangle has effectively been slid to the right, and we've cut off some of the original input from our very first generation. We can now effectively pass this to the large language model again as input and get a new output. An important caveat here is that most providers, so for again, example, OpenAI, will not implement this sliding window for you. So you have to, as a development team, manage this yourself. And this also means when you are passing input to do a generation, for example, with OpenAI, they will mandate that the number of input tokens, as well as the output that you're looking to generate, fits within the context window. And again, this comes back to that process that I was saying before, where it's iterative. Each token is getting predicted at a time based on all the previous tokens before it. So we need the full answer to fit in there as well when we're doing this as an iterative process. Okay, so you also now have an understanding of context window. We'll finish this talk speaking about some of the major prompt types and categories that you use. So in general, there are three primary prompt types, that is system, assistant, and user. To begin with, we'll speak about system prompt. And not every model is going to have this, but most these days will. Effectively, you can use the system prompt to provide your baseline instructions for what you want the language model to do. So in the template that I showed earlier in this presentation, that you could think of as what you would provide in your system prompt. The user prompt is anything that is provided from the user as input to the large language model. So this makes a lot of sense if it's a chatbot style system. You're passing the user input with the prompt that goes to the language model. That's clearly the input, that's your prompt to the language model. But you can still also use the user prompt type in a single generation case. So for example, if you're doing a classification task, you might say in your system prompt, your instructions for how to classify and what the language model should be classifying. And then you can provide a single user prompt, which is the example that you want to classify. You will then receive an output, which will be the assistant prompt that you can analyze and post-process. So as you might have inferred from that example, the assistant prompt is the name that we give for any outputs of the language model. So any of the generations we call the assistant prompt. And again, this is more intuitive in the idea of a conversational setting, because from our definition before, everything that goes to the large language model as input, we're considering our prompt. So in a conversational setting, as the conversation goes on, we're passing pairs of the user and the assistant messages as input to the language model. So in this sense, we can view the assistant message as also being a prompt. But for a single use case, it doesn't necessarily make sense to specifically view this as a prompt. Regardless, these are the three primary prompt types and versions of messages that you'll be providing and receiving from a large language model. Finally, as a brief addendum to this presentation, let's speak about hard and soft prompts. Hard prompts are effectively what you've already been using. They're the examples that I've provided in this presentation, and they're the primary way that you'll interact with the language model, and they should be the primary way. If for some reason though, the hard prompt hasn't been effective, you might consider soft prompts. So again, to recap, hard prompts, they're your standard form of input. They have the benefit of being human understandable and human readable, but there's a significant limitation in that you'll soon realize as well, if you're working with language models, coming up with the best prompt can be quite challenging. Soft prompts address this by instead viewing the prompt as learnable parameters. And if we have this idea of a learnable parameter, then we can adopt the same training process that we used to train the original large language model to come up with what is the best prompt. And that process is called backpropagation. So via this process of backpropagation, we'll update the prompt, which we're now viewing as learnable parameters, so they're numbers, to determine what is optimal for this specific use case. So that has one extremely strong benefit, which is you have now a process to improve and to numerically optimize and come up with what is the best prompt for this use case. But it has a second and potentially even more important downside, which is, as a human now trying to read this, it doesn't make sense. It's numbers. There's no human readable format here, which makes it difficult to debug and makes it difficult to iterate on yourself. To further highlight how the soft prompt works here, we effectively take our soft prompt now, which is these learned numbers, and we append them, we concatenate them with the original input tokens from the user, and we pass now this whole input as the new input tokens for the language model to get our output on. Okay, so that has been an overview of core prompt terminology and how and why to use prompts. I hope you found it useful. If you have any questions about deploying AI features and leveraging prompts, feel free to email info@aragoai.com. Thank you.